Unveiling the cosmos. Has the James Webb telescope broken reality? This revolutionary telescope challenges the Big Bang hypothesis and dares to unveil the unfathomable truth. Do we live inside a massive black hole? Take a mind-bending voyage with the James Webb telescope into astrophysical uncertainty. Will it reveal our cosmic existence or plunge us deeper into the enigma? Prepare for a cosmic revelation. The scientific community was once again taken aback by a finding from the James Webb Space Telescope, which has become famous for its groundbreaking discoveries. The telescope has offered a mind-boggling idea about our cosmic address through its careful investigations and cutting-edge instruments. The likelihood that we live within the limits of a black hole. This revolutionary idea calls into question our most basic assumptions about the cosmos and our own existence. This bold assertion is supported by data collected by the telescope over a long period of observation. Researchers are currently dissecting the data in an effort to prove this astounding theory. If confirmed, this finding would significantly alter our understanding of how black holes emerge and the enormous effect they have on the fabric of space-time. It would require cosmologists and scientists to rethink our understanding of the universe. As the scientific world tries to come to terms with this paradigm-shifting discovery, more study and investigation into our possible future black hole home will be necessary. The James Webb Space Telescope keeps calling to us, urging us to look further into the cosmos than we've ever thought possible. Black holes are mysterious cosmological entities that capture the curiosity of both professional astronomers and amateur astronomers alike. They denote regions of space that are endowed with an exceptional gravitational pull, one that is so intense that nothing, not even light, can escape its grasp. A singularity, also known as a point of infinite density and infinite gravity, can be found at the center of a black hole. This is the point at which the physical rules begin to fail. A black hole is formed when matter collapses under its own weight, producing an event horizon in the process. This is a barrier that lies beyond where nothing can be observed or detected. Because a black hole exerts such an enormous gravitational pull on its surroundings, space and time are warped as a result. This results in the formation of a gravitational well from which there is no way out. Even particles moving at the speed of light are eventually sucked into the mouth of the black hole. These infinite peculiarities, which are remembered to have started from the delayed consequences from enormous inestimable impacts or from the leftovers of massive stars, never quit astonishing and testing our perception of the universe. An entrancing discipline that pushes the limits of human information and gives huge experiences into the idea of room, time, and gravity is the investigation of dark openings and their way of behaving. This area of examination is known as dark opening astronomy. There are two remarkable phenomena that can be found throughout the vastness of the universe: stellar black holes and supermassive black holes. Stellar black holes are formed from the stellar remnants of enormous stars that have run out of nuclear fuel and then collapsed under their own gravity after reaching their limit. As these stars go through the process of supernova explosions, the cores of their bodies implode, creating a mass that is so dense that it is known as a black hole. Stellar black holes are relatively smaller in size, but they possess an enormous gravitational attraction that engulfs anything that is within their event horizon. Stellar black holes can consume everything in their vicinity. In sharp contrast, supermassive black holes, which reside at the centers of galaxies, have an astounding scale. These cosmic behemoths have masses that are thousands, millions, or even billions of times greater than that of the Sun. Although the origin of supermassive black holes is still a topic of active investigation in the scientific community, the preponderance of opinion holds that these objects come into existence as a result of a process that involves accretion, mergers, and the slow buildup of star matter and interstellar gas over cosmic periods. Not only does the discovery that stellar black holes as well as supermassive black holes exist captivate the imagination, but it also makes a significant contribution to our understanding of the intricate mechanics that govern the universe. Some researchers in the scientific community are open to the interesting idea that the origin of our universe might be traced back to a mysterious occurrence known as a black hole. This fascinating theory postulates that the seed of our universe and the very beginning of all that we are aware of erupted from the depths of a black hole. This would make the black hole the origin of everything that we know. These researchers are proposing that the fabric of space-time becomes twisted and deformed when subjected to the harsh conditions that exist at the heart of a black hole. Gravity is the dominant force in this region. It's possible that an infant universe was conceived inside of this cosmic cauldron by a singularity, also known as a point of infinite density. The Big Bang is the name given to the phenomenon that followed, which was the fast expansion of this hypothetical universe. This event is credited with starting the progression of time, space, and matter into their current states. Notwithstanding the way that this hypothesis is still in its beginning phases of advancement, its allies keep up with that it can reveal insight into probably the most principal questions that encompass our reality. It presents a test to our perspective on the world and persuades us to seek new lines of inquiry in mainstream researchers by empowering us to consider the idea of dark openings as the makers of the universe. When an intensive spinning motion is introduced into a black hole, a critical juncture is reached in the compacting process that is taking place inside the black hole. This process is characterized by the gravitational collapse of huge astronomical objects, at some point in the process of the black hole amassing more matter and contracting under the influence of its own gravitational pull. A threshold is achieved at which the rotation becomes accelerated, producing an extraordinary quantity of torque. This quick rotation triggers a fundamental alteration within the structure of the black hole, which brings an end to the process of compacting the space around the black hole. The tremendous torque that is produced by the spinning motion acts as a counterforce to the gravitational force, effectively balancing the inward pressure that is the primary driver of the collapse. The moment when the process of compacting comes to an end is an important landmark in the development of the black hole. At this point, the strong rotational energy of the black hole begins to change its characteristics and begin to shape its one-of-a-kind attributes. The rapid spinning motion causes a twist to be introduced into the fabric of space-time, which results in the formation of a swirling vortex that has a profound impact on the environment that is around it. Even while these specific mechanisms underpinning the interaction of torque and gravitational collapse within a spinning black hole are still areas of continuing scientific investigation and exploration, they offer tantalizing clues into the nature of these mysterious cosmological events. The mysterious nature of black holes has always fascinated scientists and fans of space exploration, and this fascination and mystery persists to this day. An intriguing notion has been proposed in recent theories. Black holes may serve as conduits, creating a possible link between worlds. The idea implies that stuff could move through these cosmic mysteries, hopping from one universe to another. In this explanation, black holes' tremendous gravitational force causes space-time to distort, resulting in a wormhole or tunnel. It is possible that matter and energy could use these hypothetical passages to travel across the enormous cosmic landscape and enter an entirely different universe. The implications of this idea for our understanding of reality, the possibility of parallel universes, and the relationships between cosmic structures are vast. While this idea is still primarily theoretical, the potential implications it has for our knowledge of the cosmos continue to entice scientists, and even though further study and investigation are needed to confirm these speculations, the possibility of black holes serving as portals to parallel universes has the potential to spark curiosity and drive the quest for understanding the cosmos beyond our own. The James Webb Space Telescope, known for its extraordinary powers to probe the depths of space, has once again made a revolutionary discovery. An ancient supermassive black hole, larger than any previously discovered object, has been spotted by the telescope in its fascinating exploration of the distant universe. A young galaxy is home to this enormous object, which is 10 million times heavier than the Sun. The discovery of this enormous black hole at the beginning of the universe reveals previously unknown details about the development of galaxies and the cosmos as a whole. The sheer size of this heavenly monster has scientists awestruck since it disproves long-held beliefs and pushes the limits of their cosmological knowledge. This astounding find pushed the limits of cosmic exploration thanks to the James Webb Space Telescope's unparalleled precision and sensitivity. Humanity's persistent curiosity and the indomitable spirit that relentlessly attempts to fathom the mysteries of the universe are exemplified by this discovery, which comes at a time when those mysteries remain shrouded in mystery. Thanks for watching. Please subscribe to our channel for more videos like this.